For our project, we have designed an LED video board to be used as an announcement display for Bethel Lutheran Church.
All right, so
Introduce yourself.
I'm Jonathan Jackson. I'm an electrical engineer. So go back. How many of you have heard of any of these?
Nobody.
No one's heard of these. Well, don't worry about it. This right here is kind of the heart of our project. It's just a web application. And the web application is responsible for creating the user interface and a number of other things.
I am Megan Buttress, and I designed the user interface. The user interface is a website and is hosted on a local area network. This is the homepage of the website. It welcomes users to the system and directs them to the proper link on the website for their needs. For example, if a user is interested in creating a new message, they are directed to click on the create link in the navigation bar. This page will prompt them to log in if they haven't already, and then they will ask for a title or topic of the message and the start and end date of their message. The time is optional, and when they click continue, they'll be prompted to add formatted text, an image file or a video file to their announcement, and multiple files can be added to a single announcement. When the user clicks submit, their announcement is added to the queue, which is stored in the document database. All lists of current announcements as well as settings and sensor values are also available through the pages on the website.
All right, so when a user creates content, it goes back to this ASP.NET thing, the web application, which then takes it and puts it in MongoDB. MongoDB is just a database. It stores the files, it stores screen content, and it stores sensor values and some settings. It's just where it puts everything. It's not a big deal. Okay, so we have everything in the database, and that's great. Now we need to get it onto the screen. So this third bit up here is a Windows application, just runs on this laptop here, and it takes all the content and it puts it on its own screen, which this hardware here that connects to the LED sign will put on the sign. So this is a screenshot of the laptop running the client Windows application. And you can see it's just taking the sign content and putting it in a very specific region of the screen. And then the hardware for the LED sign then takes that and blows it up to the corner of the sign. So I think that's all we got to do that.
So Jonathan's application sends that to the Linsen receiver. This is kind of a rough outline of how the circuitry is set up. Basically, the Linsen receiver transmits it to the panel, and it has 16 output ports that basically can display 32 pixels wide and 64 pixels high. So each one goes to a 16 port, and then it displays on each column of the screen. The heart behind the program is basically a Python program that runs inside the Raspberry Pi. The Raspberry Pi, you want to hit one more time, controls basically a temperature sensor and a light sensor, and it also receives data from Jonathan's website that tells the screen if it should be on or off at a given time. It uses a get function to receive the maximum and minimum temperature, the safe temperatures that the screen will continue to run. And it uses send information to relay how bright it is in the room so the screen knows to be at its full brightness or at a dimmed level. And then obviously it receives the time that it should be on. So if in the middle of the night you can have the screen shut off to save power. So yeah.
So when his program has set these values, the web application takes them and it stores them into that database with other information. And so this is just like a list of sensor values. The next slide there. We can see that those could be formatted with a histogram so that the user can configure this sign with information knowing, like what is the maximum value of light that this thing has ever seen, and then set parameters accordingly. And after that, any questions?